So now let's talk about a different quantity that is called the resistivity. So the resistivity is a quantity here. So rho is called the resistivity. And for any given material, we can say that the resistance is given by rho times L over A, where L is the length and A is the cross-sectional area. Cross-section area. So this just tells me that if you want to calculate resistance, look up the value of the resistivity, look up the value of the length, and look up the value of the area. And then you can use this table to calculate the value of the resistivity. So with this, I want to just take one more example here. So we're going to look at copper, for example. So let's look at copper. And we'll look at the value of, so this is the resistivity of copper. And then let's look at the second example here, that is glass. So glass is between 10 to the power 10 to 10 to the power 14. So with this, let me solve one example here. So I want to share my other screen. So this is the equation that you use to calculate resistance. So resistance is resistivity times length or area. And so what I'm going to do is that I'm going to take two types of, so let's take, so this is my copper. And this is my glass. Now for each of these, I'm just going to say that the area, let's take the area to be equals to, let's say, let's just say that this is 10 to the negative 6 meters squared. So the same area, so 10 to the negative 6 meters squared. And when I talk about area, I'm talking about this cross-sectional area here. And then we'll also say that the length is the same, so we'll just use the length of 1.0 meters. Now the difference is that the resistivity for copper and the resistivity for glass are different. So when I look up this on that table, for copper I get, it's about 1.6 times 10 to the negative 8, so 1.6 times 10 to the negative 8. And this is in a unit that is called ohm. So the unit here is in ohm times a meter. For glass, the value is about, let's just say 10 to the power 10. So using these, let's calculate the resistance for copper. So this would be the rho value, so resistivity of copper times length over area. And for glass, this would be resistivity of glass times length over area. So if you go ahead and plug in those values here, this would be 1.6 times 10 to the negative 8. And then the length is just equals to 1. The area is equals to 10 to the negative 6. This would be 10 to the power 10. The length is 1, the area is 10 to the negative 6. Now you can, if you solve this equation correctly, you're going to see that for copper, you get something like 1.6 times 10 to the negative 2 ohms. Meanwhile, for glass, you get something like 10 to the power 16 ohms. So in this example, for the same length, so if you take for the same length of copper and glass, notice that the resistance of copper is very small, but the resistance of glass is very high. So again, this tells you that glass is a good conductor. Copper is a good conductor and glass is a bad conductor.